Today we're going to be having a conversation about outsmarting the hackers and what that actually means. So when we say outsmarting the hackers, we don't necessarily mean this constant battle of there's some person halfway across the world trying to hack into your system. We're talking about preventative, sensible measures that we can take as software engineers, as information security experts, as sysadmins, to better understand our systems and view it from the perspective of a malicious intruder. Next slide, please. So, hi, I'm Chris. I am a senior cloud engineer in another life, and I'm also a developer advocate for Sainsbury's for Coralogix. So most of what I do is outreach and starting webinars late. Sorry about that. With me is Yuval, the star of the show. So Yuval, would you like to introduce yourself?
Okay. So I'm currently working as a cyber solutions architect at Coralogix. I have quite a vast experience in various IT and software development, architecture, and cybersecurity from past companies that I worked at. And prior to working at Coralogix, I worked as a consultant for many leading global companies and organizations throughout the world. Worked as a CTO for a large insurance agency in Israel. And the first software I developed was a small word processor at the age of 14.
Wow. The first software?
The first software I've ever developed, yeah.
Mine was a Hello World app written in VB.NET. Oh, okay, I'm outclassed already. It's not a good start for me. We'll move swiftly on before I get embarrassed even more. Next slide, please. So today we're going to cover a range of topics. They're broken into the basics and the advanced. We're not going to go into super detail on the basics because a lot of people on this call already know them. Certainly as a software engineer myself, I've run into these approaches and techniques many, many times. However, everything above that is not things that I've thought about before. And these are things that you are hopefully going to shine a light on. And when we leave this webinar today, hopefully we'll leave it with a better insight into how to view your system a little bit like a hacker, but also how to prevent these attacks and be resilient to these attacks when they do happen. And most importantly, when they have happened, piecing together the puzzle to try and work out what went on. So next slide, please. So what is your system? This might seem like an obvious question. Many of you will know your architecture diagram. You will know your cloud provider. If you deploy your application out onto mobile devices, you'll know all about those mobile devices, screen sizes, processors, RAM chips, hardware vulnerabilities, all sorts. However, your system is much more than that. As a software engineer, I think AWS, EC2 containers, that kind of thing. But I never really think about the things that my employees might be using. So Yuval, from an information security perspective, what is your system?
Well, this is actually one of those questions that you can answer very quickly and then think and realize that you're wrong, that it is much more complicated than what you originally thought. For example, in the recent COVID-19 pandemic, many organizations, and I actually just heard from my friends at one of the companies I once worked at, that they have about 1,000 employees, about 800 employees at the moment, and there 500 of them are working at home right now. So that means that your boundaries of your system span from the newest employee that reached your company's laptop or even his mobile phone throughout the data centers and cloud infrastructures that you currently have, and even your business partners. Because, for example, what we just learned, or again, the lesson that we have learned again from the recent attack on, forget the name, the attack on SolarWinds, has taught us again that sometimes your infrastructure or your system spans even to your business partners like SolarWinds, because people can change it and affect your system eventually. That means that it's partially there.
That's a scary idea, that, because as you know, again, in modern software engineering, you work with lots and lots of companies, lots and lots of different providers, lots and lots of libraries, and the attack surface is enormous, right?
Amazingly so, because currently over 90% of organizations use open source software, open source code, libraries, etc. No one actually, no software engineer would bother to take a look at the source code of each library that he would integrate into his own code. This is madness. No one would do that.
Mm-hmm.
But at the end of the day, someone can, and it definitely happened before, that people with malicious intents modified open source software to exactly impact your organization or many other organizations that use that piece of software. So that means that the boundaries of your system actually have exploded, which eventually sort of killed the perimeter security paradigm that was the dominant in the until a few years ago in many organizations as the way to manage security in the organization, because perimeter is no longer there.
Yeah. Yes, the perimeter is no longer there. It strikes fear into many of the heart of InfoSec reps everywhere, I think. So next slide, please. I thought it'd be good to end on perimeter is no longer there. That's ominous enough, for a security webinar. So the basics. So in my capacity as a software engineer over the years, I've run into these sort of basic principles. So regular patching and maintenance, for example, it's just the act of keeping track of the versions of your AMIs, your software, the third-party libraries you're using, and making sure that you're constantly up to date with them. The theory being is that bug fixes and vulnerabilities will be patched in these later versions, and you can always stay ahead of what's called known vulnerabilities. So these are the ones that have already been released, the software vendor knows about them, and they're already kind of sorted and hooked up. IDS rules are a little bit more interesting. So an intrusion detection system will filter. You can have it in multiple modes, which Yuval can explain in more detail, but they're basically a set of rules that can filter through filter your traffic and things like that and flag up alerts, and they can form part of orchestration systems as well. So if some traffic starts coming from a certain IP range that you've already put an IDS rule in there for, it can either block the traffic or flag an alert, send an email, that kind of stuff. Finally, scanning for common vulnerabilities. So you'll see this all over the place. HTTP API scanners, web application scanners, code scanners, things that will just look for that top 10 list of vulnerabilities. I think OWASP has like a top 10 list, and they're usually things like SQL injection attacks, cross-site scripting attacks, that kind of thing. So these are the things that as a software engineer I think of. But Yuval's here to tell me why I've been essentially living in an information security cave. And so next slide, please. Yuval, I'll put you on the spot, but why, if I just do these things as an engineer and then I go, okay, we're secure, why isn't that enough?
Well, first of all, let's start with let's break it apart to every component that you just mentioned. So firewall rules, and it doesn't really matter whether it's a firewall, a TCP/IP firewall, or more complicated or more advanced sort of firewalls. Their configuration is essentially fragile, in the sense that most of them are using the break on first match algorithm to say that it says that there is a list of rules, and the first one to match the traffic that is currently passing through the firewall will be will determine whether that traffic would be allowed or blocked. And if, for example, the firewall manager would move a few rules around to open something that was closed by mistake, it may very well also open other things that shouldn't have been opened to the world, or vice versa, or opened from the world to your organization. It is very common to see that people do that by mistake. And patching is actually, for example, in the recent SolarWinds attack, was actually part of the problem. You patched your software so quickly that you got a malicious patch from SolarWinds because someone attacked SolarWinds. So it's actually not easy to tell whether it's part of the solution or part of the problem. IDS rules can allow you to create rules that would, and you can even get lots of ready-made rules from the community, from other companies that create those rules for you. And those rules tend to be very, very noisy. Meaning that you would get eventually to the point that you will get an analyst fatigue or alert fatigue, meaning that you won't be able to sift through all those alerts in real time and really respond to those that matter. I've seen it happening so many times in the past that people say that people that worked at the SOC or something like that, they get those alerts and say, well, this is probably a false positive, and just dismiss that. And it is very common because no one can actually go through the number of those rules to really make sense of them. And vulnerability scanning would actually prepare you for yesterday's attack, if you're lucky, because it doesn't give you anything. It will never detect an attack that is just new, or what we call a zero-day attack. And it would never detect something. After all, every attack is essentially something abnormal, something that is new. And vulnerability scan looks at your files, at your network behavior, lots of patterns, and would say, this looks like some attack that happened back in 2000 or something like that. It might be true, it might be wrong, it might be relevant, which happens a lot, but it will never prepare you for the real attack that would be launched tomorrow. And that brings actually the question that I get very often is why detect something? People say to me, why should I detect things when I can prevent them? But maybe I'll leave that to later.
It's an interesting question, right? I think people get a little bit, they underestimate the complexity of just pure prevention, right? We just think that I've built Fort Knox, no one will ever get into this thing. And then obviously, inevitably you put that out into the universe, and somewhere across the world a hacker hears that and they go, okay, challenge accepted. Next slide, please.
That's true. Maybe just one tiny comment about the previous slide. The real reason maybe why the basics are not enough is that attending to all the basics would keep you single-minded, instead of multidisciplinary security, because I've seen it also happen a lot that a software developer would say, well, I'm using that piece of software, it is secure, and I'm using HTTPS. Well, I'm perfectly all right. And it must be okay. And the network guy would say, well, I'm using the correct segmentation and such, so it must be okay. And the organization is not okay. And no one actually can see that if you always see just part of the puzzle. But we will address that maybe in the next slide.
Next slide, please. So one of the things that I bump into a lot as a when I'm building and operating a system is that I find myself dancing across 10, 15 different monitoring or observability tools, or I am pulling logs from here, I'm SSHing onto this server and pulling that from there. These metrics are coming from Prometheus, or they might be coming from Thanos, and there's a bloody distributed Prometheus cluster underneath. But the argument here that we're trying to make is why a single observability platform and how this improves your ability to react to security incidents. So why a single observability platform, Yuval, rather than all these tools?
Mm-hmm. So a single observability platform actually solves the problem by allowing you to be multidisciplinary about security. It would allow you to gather all the knowledge from all the different types of information that you might have. It can be from the development perspective, software development perspective, meaning that you would be able to know when and where someone published a new version of your product, whether that was normal or not, and what your servers are doing, and whether that is normal or not, and would it allow you to see what your users are doing, and what your administrators are doing, and what your network routers, switches, everything, and to get a whole picture of everything that makes up your organization. And this is the only way that you can actually see everything through a single pane of glass, and be sure that you at least know everything. And on top of that, if you have the correct alerts capability, for example, to say if that happened and then within a certain amount of time that happened, then I would like to know about that. This is only possible if you have all the types of information in a single place. And to do what is known as hunting, this is also almost impossible to do if you have to get the logs from your firewall, and then the logs from your the software, and then the logs from your CI/CD, and then the packets that were saved somewhere. To combine everything, it is very tedious and sometimes impossible. Depending, of course, if you're a large organization, becomes a completely impossible task to do. But with a single observability platform, this can become possible. Yeah.
Very good. Thank you. So, I mean, well argued, I suppose. I can't really think of any devil's advocate arguments to make against that. So, next slide, please. Obviously, people are free to ask questions whenever they like throughout as well, just remind everybody. So left shifting, this is something that I've experienced a little bit. It's a bit of a buzzword these days. You see people want to left shift everything. What left shifting essentially means is if you imagine your software engineering, your software development lifecycle in one big line, security usually traditionally comes towards the end, right? You build the thing, you test the thing, okay, it's functional, you throw a load of load at it, okay, it performs, and then you try and hack it, oh God, it's all insecure, and then you go back again and you fix everything. And that would be an example of right shifting security. So you're putting the security conversation right at the end of the software development lifecycle. However, in the past few years, you've seen this idea of, okay, let's stop security being an afterthought or a bolt-on or a capability that we sort of just munge into the code. Let's make it part of the design. When we build our system, let's have security people in the room, or let's ourselves take that security ownership and think about that while we're designing our software. Yuval, in your experience, when people do this, how do you feel it impacts the security conversation? And do you think there are any drawbacks to this approach at all?
Actually, I think that it's a very good decision to do that, because security is not, in the early days, people thought that security is part of the network. It was a responsibility of the network guys. I just developed my software, and you, the network guy, would keep it safe by preventing everybody that is not authorized to reach it. But it's now it has been proven to be nonsense, because security is everywhere. Security is in the design of your software. It is in the design of your network. It is in the way that you use your software, and even in the sometimes it's even an architectural kind of problem. I've seen several pieces of software that use, for example, an Microsoft Access, for example, as their front end of the software that they build. That means that if you deploy it in an organization that has several branches or spans over multiple different geographical regions, that means that the IT guy would be forced to allow SQL port from any of those regions to the core of the organization, to the database server, because this is what Microsoft SQL requires. And that means that if a malware would attack one of those endpoints, one of those user machines, it would be able to reach the SQL without any restrictions whatsoever. So this is just one example, but I can add lots of others. For example, many types of software that I've seen, they tried to create an update mechanism for their software, and the way they did that was essentially by creating a set of several servers up in the cloud that are FTP servers, and they use a single domain name, for example, and that allows the company, the software company, to launch more FTP servers if they need to scale up. That means that for the IT guy, that he would have to allow FTP connections from the organization to an unknown IP address. And that means that it's from the firewall's perspective, it's sometimes even impossible to say whether this FTP connection is pulling data or sending data. It's not necessarily possible for the firewall to detect that. Depends on whether the connection is encrypted or not, and several other considerations. But so that means that the security is really everywhere. Even if you develop software, and just like I explained it before in our private conversation, that that over 90% of the organizations today use open source software, and no software developer would actually bother to look at every library that he imports into his code to make sure that no one puts malicious code in it. And actually, it happens quite often. And in the past year, in 2020, the number of attacks on the supply chain attacks rose up by 450%.
Sorry, 450%.
Yeah. So this is quite amazing, and this is exactly what I meant. That security is everywhere. It's in the design. It's in the design of the network, design of the code, and even in the choices that you make about whether to import that module or that module, whether that open source, that GitHub repo is secure. I mean, the code that is in there. Is it secure? Is it maintained enough? Many software developers don't make those decisions at all. They choose what is comfortable for them to work with.
And that ties in nicely with one of the questions. So just a quick recap to what is left shifting. The left shifting is very nicely encapsulated by what Yuval just said there, which is the software engineers and potentially some experts making the security decision at the point of design. So let's design this in a secure way, rather than software engineers build it, and then at some point later down the conveyor belt, somebody securifies it. Security is kind of part of the design. It's part of the software engineering process, not part of some other QA process that's kind of considered separate. That's what left shifting is in a nutshell, very eloquently described by Yuval there. Great question came in. What's the most common attack that Coralogix detects on web apps? So is there something that really comes up all the time?
I think that it's not, Coralogix is not for detecting a specific attack on web apps or on, I don't know, database servers. I think that Coralogix is about detecting security issues, and I think that we will address that in a few slides. So
yes, so it's a teaser there. Those are some webinar skills you pick up, right? Next slide, please. As the most commonly missed components, techniques, and metrics. Okay, Yuval, I'll tell you the ones that I look at, and then you can tell me why I'm an idiot. So I go normal HTTP traffic because I can see it. Error logs, like I look for like 400s, 401s, that kind of thing, and maybe 500s. But I would guess they're the pretty normal ones, right?
Yeah, I think that many people, when they look at security, they would choose one of several approaches. One of the dominant, I think, security approach that people use by mistake, but they still use, is a security in a box. I will purchase that software, or purchase that EDR, or purchase that box, install it, and then I'm secure, right? Because I purchased the best firewall in the market. I purchased the best WAF. I purchased the best EDR, and they actually are not, because security is not about the tools that you use as much as it is about the way you think, the way you do things in general. At all, and it can be the way you handle technology, but it's much more than that. So from a technology perspective, technological perspective, one of the things that I see that are missed most is DNS, because DNS is often thought as something that is probably won't tell me much, because it's the way things actually work in the internet world. So I would look for files. I would look for malicious files, for signatures, or for malicious behaviors. But if you just get an information about DNS traffic in your organization, period, not about DNS requests from your DNS server necessarily, but any DNS traffic on your network, the things that you can get is really amazing. It can detect, since DNS is essentially based on UDP traffic, that means that there is no connection. That means that everything that you need to know is in that packet, even if it didn't reach its destination at all. Even if your firewall blocks port 53, for example, to the internet from every endpoint except for your DNS servers, you record every DNS packet on the network and analyze it properly. You would be able to tell if computers on your network are trying to get to a remote DNS server.
So how would you tell? Like, how would you know the difference between a malicious attack, a malicious piece of software that's trying to hit a DNS server, and my cat picture app, for example?
First of all, if your organization uses DNS in, for example, recursive lookups, if it allows recursive lookups on your DNS, and this brings us back to the fact that security is in everything that you do. And if you allow recursive lookups, that means that your endpoint, your servers, for example, will never try to contact a remote DNS server directly, because they will always should contact your DNS servers first, and they will do the query for them because it is a recursive lookups. And if you do see a connection or a connection attempt from your DNS from one of your servers to a remote DNS server, that is probably an indication that something is bad, something is wrong. It can be configuration issue, but it is very likely that something is running on that server and trying to do, for example, DNS tunneling to reach to some other endpoint on the network, on the internet. And DNS is a very good place to start, because every connection, even the encrypted ones, eventually would start with a DNS query. And this is a good resource, a very good resource that is often, quite often overlooked, to tell which places your organization is trying to connect to. And for example, if we talked about earlier, we talked about the open source software that someone would download or import packages from everywhere without analyzing them and investigating them properly to make sure that they are not, for example, handling a connection to a command and control server or somewhere. If your servers, you installed, I don't know, a library on that server that supposes that should be responsible for example, doing some statistic calculation or something. And that server, since that installation started contacting a new domain, that would give you an indication that something is wrong. And if you investigate a bit further, sometimes you will find out that the reason for that was exactly that installation of that package, of that library that you imported.
I think that actually pulls us really, really nicely into the next slide, if you don't mind, because what you just touched upon there is exactly a perfect thread. Don't just look at vulnerabilities, look at information, right? So doing DNS lookups isn't a vulnerability, right? It couldn't be, otherwise nothing could work. However, what you're arguing here is that in the same way that a hacker might look at your system and they won't necessarily scan for vulnerabilities. They'll just look for stuff. So, oh, how does that work? How does this work? How do they do this? So, am I on the right lines there? Is that yes. How you'd approach the problem?
Yes, I think that in generally what you need to do is to think, and this is regarding the question that was asked just a while ago about whether Coralogix would detect which types of attacks would be detected by Coralogix on web apps. The idea that we are trying to promote here is a bit different, is that you, and actually sometimes we will do it, we'll do some of it for you, is that to think what can benefit hackers if they come into your network, and then to find out from those things, things that would stand out, that in which you are unique, and by doing those activities in your network, in your infrastructure, they would stand out. And I can give several examples for that. For example, I've seen organizations that use some library that would make HTTP connections more efficient by compressing the traffic, or by modifying it in some ways to keep the connections to keep the connection running instead of disconnecting and reconnecting again. But the important thing is that it would choose a specific different port for that communication. So in those organizations that use that across the board for every communication in HTTP that they do, I've seen that there is absolutely no connection in port 80 or port 443. So I said, well, an attacker that would come to that network will never know that and will always try to hide itself by trying to use port 80 or port 443. And exactly this is something that I immediately put an alert on and said, well, if that happens, I'm positive that it's not them because they are using that library.
Exactly. That's interesting. So it's that looking for what makes you unique as an organization, right? Is that just technologically unique, or is it also business unique as well?
It can be anything, as long as it can be anything, as long as you think that it would also benefit a hacker. Right. And if you do that properly, and like I said, Coralogix as a company can help you do that. Both with a platform and both with its personnel. But it can be, for example, working hours. Some companies are very strict about their working hours. After 4 p.m., there is nobody left at the office. If that's the case, put an alert immediately about logins after that, past that hour, and you would find something, even a login attempt, even if it's a failed one, or even if it's not a failed one, it's actually even more important to notice. And I've seen, for example, organizations that use the way they print documents at the office can be either through a printer server or directly connecting from any user workstation to the printer directly. If they are using a printer server, for example, then any attempt to connect from a computer to the printer server, to the printers directly, would be considered something worth taking a look at. And also, if you know that all of your printers are located in a specific segment, for example, you know that this segment is used for printers, or it can be IP phones or something like that. If you see connections coming from them to any endpoint on the network, then it would be suspicious, because no printer should ever contact a computer directly. And actually, there have been attacks in which printers depend on firmware updates, which are patched very much less frequently than computers. In many organizations, so they are very common to be attacked by attackers, and then they try to pivot from the printer to other computers and scan the network. If you see something like that, you know that it is a printer, and it is much easier for you to set an alert for that in advance. I've seen organizations that use that don't allow their employees to browse the internet directly from their computers, but instead of that, what they do, they use RDP-based solutions or other solutions that essentially use keystrokes and get and mouse movements to a server and get back the images of the web pages that you are currently browsing. And if this is the case in your organization, then an alert saying, if you see activity that goes to outbound IPs directly from any computer on the network, then I would like to know about it. Even if it failed because the firewall blocked them, I would still want to know that it actually happened. And I can go on.
Yeah, this seems like a good wrapping up point. We've kind of defined quite well the thinking like a hacker thing, right? Which is, rather than just thinking like a software engineer,
Yes.
approaching it like somebody from outside of the system and thinking, okay, what makes these guys unique? What do these people do differently? What's new about these people? And how can I exploit that in an unknown, novel, and interesting way?
Yes,
that's pretty much. We're going to have to wrap up, I'm afraid. We pretty much all we got time for. We started late.
Just
yes,
a
go ahead.
sentence about that is that the hardest thing for an attacker would be to build not one malware for every organization in the world, but to build one malware per organization that he would like to attack. This is immensely more difficult, and no attacker in the right mind would do that. And if you make yourself unique by doing all those things, you're essentially taking the problem taking a technological problem and making it an intelligence problem for the attacker to know what makes you unique and make your attack specific for you, which is something that he wouldn't be able to do in many cases.
Brilliant. Thank you very much, Yuval.